Hello friends, in the last video we have seen integration. We just started integration as antiderivative. But now I'll just explain this concept of integration as area under a curve. Okay, let us see how. I have one curve here. This is my x-axis and this is my y-axis, and this is the curve. And the curve is y is equal to f of x. Right? Now I have to find the area under this curve. Okay, but then I should have some, right? I should have I must specify under what limits. So area under the curve and maybe between area between these 2 points A and B. Okay, this is my this point is, let us say, a comma 0, and this point is b comma 0. Correct? So then if the curve is y is equal to fx, then what would be y coordinate here? Y coordinate would be f of a here, right? So 0 comma f of a, and y coordinate over here for this, it would be coordinates of b. So it would be okay, 0 comma f of b. Correct? So my point A is a comma f of a, and point B is b comma f of b. Correct? And what I want to do is I want to find this area, I'll say PQ. I want to find area PABQ. Now I don't know what is the area, right? Is it a normal or some regular shape like a square or a rectangle or a triangle or a trapezium or a rhombus or a parallelogram, anything? I can't say. It's not. Correct? So now what I do? I'll take one small strip. One small strip. Okay? This is a strip. Okay? And one end of this strip, I am going to call it, it was PQ, right? I'll say it is ABC. Now the left end of the strip, okay, it is cutting the x-axis at C, and the right end is cutting at D. Correct? So this strip of width CD, and then width CD is equal to dx. So when I am calling strip D as dx, what is the thickness of strip? Dx. Is it not infinitesimally small value? This CD is a very small value. It's a very small strip. Maybe even thinner than my hair. Okay, hair is a very thick thing. Okay, it is very thin. Okay, now suppose, now I tell you that I'm holding one hair in my fingers. Can you see? You can't see, but I'm having it. But now even I cannot see. But if I say the thickness of the hair in my fingers, in my pinch here, if it is dx, then you have to agree with me. You have to believe. Okay, but then when I take maybe hundreds of this hair, okay, if I hold a bunch of hair, then you can see, isn't it? So individual dx will not be seen with your naked eyes, but then you have to take it as it is. Okay, now what I'm going to do is this point C is at a distance x from here, and then this thickness is dx. Correct? Now, if this is x, then what is the coordinate of this point, y coordinate? Is it not fx? So it would be the coordinate of this point CD, and if I call this E and F, okay, so C is equal to x comma 0, D is equal to x plus dx comma 0, correct? My E is equal to, E how much? E is equal to x comma f of x, and f is equal to x plus dx, and that would be y plus f of x plus dx. Okay. Now if you have to find the area of the strip, what would be the area of strip? Area of the strip would be its x coordinate here. Okay, so that means how much is this distance? Fx, right? This distance CE, area of strip CEFD is equal to CE into CD. I am going to treat it as a rectangular strip now, because my dx is very small, correct? So a small portion of the curve is going to be, I can approximate it to a rectangle, I mean a straight portion there. So CE into CD, and then what is CE? CE, is it not fx? CE, it is fx into CD is dx, right? Now I want to find this whole area from PABQ. So what I'll do, I'll take one strip here, one strip here, one strip here, here, and I'll finally reach here. I'm adding all the strips, right? So when I say I'm adding, I'm integrating them, correct? So area, so my required area PABQ is integration of all the strips, all such strips fx dx. So that is how integration is area under a curve. Now I wanted area PABQ, isn't it? So my x should take which values? X takes values from A to B. So then my lower limit is A and upper limit is B. So if I do that, then I get the exact area of that part. Now here, now I'll quickly give you an example here. Now instead of having that curve y is equal to fx, if I take a straight line, and this is the straight line, okay, I want to find this area, correct? Now what is the equation of this straight line? Y is equal to 3x. Y is equal to 3x is a straight line, correct? And this is my x is equal to 3 and x is equal to 6. I want to find this area, okay? Then my area, I'll call this A, B, C, D, okay? So now I want to find area ABCD, and I have y is equal to 3x. So area ABCD is equal to, and between x equal to 3 and x equal to 6, 3 to 6. Now I write 3x dx according to what we did previously. We just integrate, correct? So now what is my integration of 3x? It will be 3 into x raised to power 2 upon 2, and that is between 3 to 6. Okay, so now that would be 3 by 2 into x square, that is 6 square, that is 36, minus 3 square is 9, so that would be 3 by 2 into 36 minus 9 is 27, so that is 81 upon 2. Okay, so now square units. Now here, shall we cross check? Is this not a trapezium and it's a combination of these two, one rectangle and one triangle, correct? Or then what is the area of trapezium? Area of trapezium ABCD is equal to half into sum of parallel sides. That is, what is sum of parallel? X is equal to 3, so y is equal to 9, correct? So B is equal to 3 comma 9 and C is equal to 6 comma 18, correct? So what is the length of this? Length of this, is it not, it's the y coordinate of B, so it would be 9 here and 18 here into this distance, so 3 and 6 here, so 6 minus 3 is 3, so it is 27 into 3, 81 by 2. So it makes sense, correct? If it makes sense for a triangle, it will make sense for all the curves, right? In the next video, we are going to talk about only the formulae for integration, which is actually going to be used as antiderivative, right? Thank you so much.